Hello and welcome back, lazy chemists. Today we're going to go ahead and go over valence electrons. And the reason that we're going to go over valence electrons is because valence electrons are secretly the most important of the electrons. They're the ones that really determine how an element's going to bond. All the other ones are, kind of just useless. They have their points, but they don't really do much at all. Okay. So for today, we're going to go ahead and go over valence electrons, and the basic is that you should be able to tell how many types of or how many valence electrons that there are in an element, and then be able to relate that to how that element is able to react, or somewhat the reactivity of the elements. Okay. Because one of the things that we'll find out throughout this year is that elements that have the same number of valence electrons often react the exact same way as another one. Okay, so first, valence electrons are the electrons in the outermost orbital or shell of the electron, or of the atom. Okay. They're the electrons that are involved in forming bonds to adjacent atoms. Therefore, the valence electrons are important for determining the number of bonds that an atom can have and the number of unpaired electrons, which is going to be something that affects the shape of the atom or the compound. Okay? And the shape of the compounds is going to be something that affects many other things. So, for instance, whether it boils at a high temperature or low temperature, whether it reacts quickly. Okay? So all these things are going to be based off of these valence electrons here. Okay, so at this point you should be able to know how to answer this question. What is a valence electron? Okay. Now, in general, on the periodic table, valence electrons are going to be dictated by their spot on it. So, for instance, this first column, all of the elements in here should have one valence electron. That's one electron on the outside rim of the atom. All the ones that are in this group should have two. Likewise, 3 in this one here, 4, 5, 6, 7, 8. Now, usually when I describe it, I usually say 1, 2, skip these few. So we're going to skip these. These are called our transition elements. These are the D block. So 1, 2, skip these few, 3, 4, 5, 6, 7, 8. So in general, if you're able to count to 8, you should have an easy time with this section and concept. However, if you are unable to count to 8, I got bad news for you. For a lot of things. Okay. Now, in general, we figure out how many there are based off of our electron diagrams. So the same diagrams that we've been drawing, we're going to go ahead and use those drawings to determine how many valence electrons there are. If its head only has electrons in the first orbital, those can only hold 2. The second orbital can hold 8. The third can hold 8 as well. And lastly, the fourth can hold up to 18 electrons. So just keep that in mind. That should be a review from the last section. Okay. And so this is just a review here, knowing how many electrons are in each orbital. Then we're going to go ahead and take a look at this one right here. Okay, this is sodium. So we need to go ahead and take a look at sodium to determine how many electrons there are. Okay, and we're trying to determine how many valence electrons we have on the outside edge. Alright, so now taking a look, we should see, hey, there is one electron on this outside edge. Okay, there's only one electron on the outside. Therefore, the valence electron for sodium is 1. Okay. Now we'll go ahead and look at hydrogen. How many electrons does this hydrogen have? Okay, so we can take a look. It has 1. What group is this atom in? Okay, as we see, it's in group 1. We can see it on the periodic table here. Then lastly, how many valence electrons does this atom have? Okay, and it has 1 electron on the outside. Therefore, its valence electrons is going to be 1. This next atom is helium. Okay, helium, you can see on the periodic table, it's here. Okay, which means that it should have 8. However, when we take a look at helium, we notice that it only has 2 electrons. Okay, so even though helium's in group 8, it's kind of like a special one. Okay, so helium's just going to be one of those special cases where even though it's in group 8, it only has 2. And that's because it has 2 electrons. Okay, since it has 2 electrons and it only has 1 energy level, we can say that it has 2 valence electrons. Next one is beryllium here. Okay, how many electrons does this atom have? And it has 4. What group is this atom in? Okay, and this atom, it's right here. It's beryllium. It's in group 2. So based off of our predictions, it should be in the category of groups that have 2 electrons on the outer shell. And as we take a look here, it has 2 electrons in the outer shell. Okay, so it has 2 valence electrons. Next is this one here. This is carbon. How many electrons does this atom have? Well, carbon is right here. It has 6. It's in 1, 2, 3, 4. It's in group 4, which means we'd expect it to have 4 electrons in its outer shell. And this image has nothing to do with carbon. Alright? So, in this case, we would go ahead, we're going to go ahead and exit out of here. So, carbon, let's dump this one here, is going to be C. It has 2 energy levels. The first energy level has 1, 2. And then the second energy level has the rest of its 6, so it's going to have 1, 2, 3, 4. So therefore, because carbon has 6 electrons total and 4 are in the outside energy level, we can say that this atom has 4 valence electrons. Okay. Oxygen is going to be very near similar. Okay, how many electrons does it have total? It has 8. 2 are going to be in the inner shell, which means that we'll have 6 left for that outer shell, which means that we would go ahead and say that this one has 6 valence electrons, and it is also in 1, 2, 3, 4, 5, 6. Okay, now I'm going to warn you. The lazy way of counting to figure out how many electrons there are in an atom is going to be counting it on the periodic table. That will work nearly every single time. Okay? Nearly every single time. The only difference is that ones like here and the ones really low right here in our post-transition elements are going to be a little bit more variable. But in general, you can count and it will work. And that's the lazy way of doing it. That's the way that I generally do it when I have to figure these out here. Okay. Now, in general, it's one of those things that you can draw them out. And this is a representation, so you should be able to count how many valence electrons are in this fluorine. You just count the outer ring. The same goes for neon. Notice that this outer ring has a total of 8, so therefore it would have 8 valence electrons. Sodium we saw before. Magnesium, it has 2 valence electrons. Aluminum, 1, 2, 3. Okay. And that will end up closing us out 4 valence electrons. You should be able to now begin work on the worksheet for this section and have a fairly easy time.